Welcome! This tutorial is aimed to be a little briefer and more concise, so it will not deal with all the pitfalls and backtrackings of the previous tutorial. If you're interested in those, then watch that separately and view this as a complement to make it work with current versions of the software required. In addition to Blender 3.4 or later is required, we will be using Elie Michel's eminent MapsModelsImporter plugin here for Blender, where we can import extracted render meshes from the RenderDoc software by Baldur Karlsson. But first we'll go to Elie Michel's MapsModelsImporter GitHub page and we'll go to releases. And for this particular release, the latest one, we see that we need Blender 3.4 or later in our experience. But if you don't get it work with a later version, make sure to use the stated version here. And then there's a hard limitation of using this precise version of RenderDoc to make it work. So first we download the Blender plugin here. If we scroll down, and then we'll download this zip file just by clicking it. And then we'll simply go to this downloaded file. And we can Ctrl+X cut this zip archive. Then we can go to the C drive, to users, to the current user, to app data, to roaming, to Blender Foundation, to Blender 4.0, to scripts, to add-ons, and then here we can simply Ctrl+V, and this is a zip archive. It will need to be extracted, so we'll do right mouse button click, and then with 7-zip you can just extract here. And now that the plugin folder has been properly extracted, we can simply delete the downloaded archive. For RenderDoc, which is a separately installed software, we will have to go to the site renderdoc.org, and then we'll have to press this other builds. And then, as you remembered here in the Elie Michel's MapsModelsImporter's plugin installation requirements, you have RenderDoc 1.25 as a hard limit. So we'll go here, and then we'll go down here to 1.25, and then since this is a 64-bit Windows operating system, we'll click the installer for 64-bit Windows. This will download the installer. Alright, and when you have downloaded the file, just open it, double-clicking, install it, clicking install to install, accept, and finish. Alright, Blender is assumed to be already installed. Let's open RenderDoc. Alright, the first thing that we need to do here is to go to Tools, Settings, and then check this option, Enable Process Injection. And as you see, we need to restart the program. OK, and close, and then we'll open it again. Let's prepare for the injection by doing File and Inject into Process. Now we won't actually have a process ID before starting Chrome in the custom state. So let's make sure that we close any already running instance of Google Chrome before opening it again in a custom state. Close. Now if you hold Windows and R, you'll start a run, and then you'll do CMD to open a command prompt. And then in the command prompt you can just copy and paste this from the description, and then you paste this in the command prompt. And enter once to confirm. And as you briefly saw, there was a dialog that popped up here. So let's Alt-Tab here, and here we have the Google Chrome Graphics Processing Unit process ID for this specific application. So 8256. Then we'll go back to RenderDoc, and then we can filter here. So 8256, refresh, and here we have it. Very good. Select it and inject. And now we have an established connection status, very good. We can Alt-Tab back to the Process ID dialog here and press OK. And you see that the API is active now, very good. So now we go to maps.google.com, and here it's important to change here in the layers pane. We change so that we are in satellite view, and also that we are in globe view. If we are not in globe view, then we will not get the photogrammetry meshes. But if we are in globe view, then we get those, and for ease of overview, in my opinion, we can uncheck labels as well. Alright, so then we position us where we want, and here's a nifty thing. what you see is what you get, but you can influence what you actually see here and what you thus will get by changing the browser zoom level. And you do this by holding Control and minus or Control and plus. And when you are in this custom zoom level, in ordinary cases you would be able to see this, but now since we are injecting into the process and this does not work, then we can't see it, but we can still do Control negative or Control minus, Control minus, Control minus. And when you change the browser zoom in level like this, you force Google Maps to show the more high resoluted level of detail meshes that there are. Because if we do Control 0 to reset the resolution for the browser here, then you will see that if we zoom in on something, it will increase its level of detail, and if we zoom out, the level of detail will decrease. These are different level of detail, so LOD levels, and in essence they are different meshes for different zoom in levels. But by changing this browser zoom here with Control and minus, we can force Google Maps to show a much more higher resoluted mesh than the one that would have been shown in a different zoom in level. And then we can Alt-Tab back into RenderDoc, and what has worked most consistently for us is that you, instead of capture the frame immediately or print screen to capture, it has actually been to capture after a delay, and then we'll do a delay of 5 seconds, so 1001, etc. And then we'll do capture after delay, Alt-Tab back here, and then we gently pan like this. And when the timer is out, you saw that we now captured frame number 6107. We'll Alt-Tab back into RenderDoc, and we see that we have it here. Very good. Let's make sure to save this file by right mouse button clicking and save, and then we'll save it in a suitable directory here. And now you can actually exit both RenderDoc and also Google Chrome. Very good. This command prompt we can close as well. Now let's open Blender. So here in Blender 3.6 we can just click outside the splash here, and then A to select everything, X to delete everything. And then we'll make sure in Preferences, we can search for Elie Michel, that MapsModelsImporter is actually enabled. Very good. And then we'll go to File and Import and import a Google Maps capture file. And then we'll navigate to where we saved it. And here, the only setting you can change is the maximum number of blocks. And for an initial test, we might do 20 blocks, just to see that we get the data imported as it should. Yes, so here we see that we get 20 blocks here from index 0 to index 19. And these do not constitute the whole model, of course, but just a portion of it, just to make sure that it works. Very good. We can select everything and delete. And then we'll go back here and do it once again. And then make sure that the max blocks is set to -1. That means an infinite limit of blocks. So now that we know that the import works in itself, and then we can just wait for it to import. The first thing we should do is to save the file. So let's Control S to save. Save it in an appropriate directory. And looking at this model, it is now composed of more than 3,600 individual meshes. It would be wise to first start by joining all of these into one. It will make all further operations more easier to handle for us. So we can select any of these actually, but we'll mark any of them as active, and then we'll type A on the keyboard and select everything. And now we join with Control J, but this will take a while. So now with all of these more than 3,600 objects joined into one object, we have to take notice here that we have over 10 million vertices here. This is a very, very complex scene and very processing demanding. Changing to edit mode with tab will probably take some time. What we want to achieve is to reduce the complexity from more than 10 million vertices to a significantly lower amount by merging vertices which are so closely together, so the effect of merging them together into one will not produce a discernible change. So let's see if we actually first zoom in here a little, and we can go down here. So we have some point of reference, and we might want to change the clipping view distance here. So we'll go here and then we'll do the clip start, can be at 1 centimeter perhaps. If we zoom in a little further, that's okay. We will not be viewing this building this far, but it might be a good reference anyway. And we have the object already selected, so pressing tab on the keyboard will enter edit mode, and here we have it. And now it looks as though all vertices are selected. Let's make sure that we are in vertex selection mode. And we can still press A once here to make sure that everything is selected. Yes, they are. Very good. And now we can press M on the keyboard and merge these vertices by distance. So we had over 10 million vertices as an outset. And now, merging with the default value, reduced 30% down to a little more than 7 million. We can see here, and this was 1 micrometer. Let's see if we can increase the merging distance to 10 micrometers and see if we get a discernible change or not. We dramatically reduced the amount of vertices. I still did not notice any discernible change. We will not be looking at this model this close, so if we do not see any change at this zoom in level, then we probably won't notice any change at a further more zoomed out level. We'll increase this to 25 micrometers then. And we are still hovering at slightly below 5 million vertices, so the merging distance might be adequately chosen. Thus, we can press Tab again to get back to object mode. And we can actually see how this looks at this stage. We can change to the material preview here. And as of now, this singular object has a lot of material slots. If we check here, it should still have all of those 3,644 material slots here. That is very inefficient if we want to use it in a separate software such as Rhino or Unreal Engine. So our first priority from here is to create a duplicate of this object, remove all material slots and only using one singular material slot, and then projecting all of the textures from these 3,644 material slots of the original object onto the one with only a single material slot. We will do that now. Now we want to make sure that all of these 3,644 texture sets are baked down or projected to a separate duplicate copy. Before duplicating and projecting, we should make sure that the transform matrix data for location, rotation and scale, and as you see, all of the sub-matrices have been manipulated. If we have this selected, and then we'll do Ctrl A and apply all transforms. This makes sure that the transform matrix is reset while all of the transform matrix manipulations have been applied to the object itself. Now we can do a new collection. We can place it here, and then we can select the collection, and with F2 we can change it to projected. And the original here we can F2 select and rename original. And then we can select the objects that we want to duplicate. Hover the mouse in this viewport here and Shift D. This will duplicate the object. And since we don't want to translate the position of the object, we don't want to move it, then we can just press right mouse button. And now everything is duplicate as a separate copy, not linked, but with no difference in its X and Y Z position. Very good. Now we can just click and drag this to the projected folder here. And to make it even more clear, we can actually rename the imported object to static mesh original and the other one to static mesh underscore projected. Now, since the projected one here, it is not projected at this stage, of course, and it still has all of the material slots, what we want to avoid in this. So what we want to do is to first make sure that we have this object selected, and then we can go to the scripting workspace here. And now here in the Python interactive console, we can make sure to copy and paste this script here. It will simply remove all material slots for any selected objects. So we'll Ctrl V there and enter again to confirm. And removing over 3,600 material slots will take some time. Depending on the version of Blender that you're using, you may get a warning here that the command is deprecated. But if you check here in the material, you see that we have no material slots, as should be. Very good. We can go back to the layout workspace. And as you see, let's make sure that we hide the projected. So you see that this is the original, it shows, and then we show the projected and hide the original. And now you see that since we have no material slots, we don't have any textures which are referenced either, so we don't have any material information here. We clearly see that we have some triangles here sticking out. Let's see if we can do something about that. For this example, I think that I would recommend to manually fill in those holes which are most prominent and then actually accept the occurrence of smaller holes. We also verified that these holes were pre-existing from the very first beginning of importing the mesh, so it's a fairly safe assumption to say that these triangular holes were also appearing in the Google Maps mesh. We just didn't see them from where we were positioned with the camera. But to fill in these holes, we can do it manually fairly quickly. We just make sure that we have the object selected, and then tab to enter edit mode, and then we'll make sure that we are in the number 2 here in the edge selection mode, and then we simply select with Shift Alt, and then we select one of the edges, and that should select all of the edges in one. Let's do it once again. Now everything is selected that are bordering a hole, and then we'll do F to fill. It might take some time due to the mesh being so very complex, like that. Since we don't have this original triangle in the imported original mesh either, what will happen during the texture projection here will not be something magical, but we'll have to see the effect on that later. Press tab to exit edit mode and re-enter object mode. Before we can project all of the textures of the originally imported mesh to the duplicate mesh, which should only have one singular material slot, we first need to properly unwrap this to be projected mesh. Since this object has almost 8 million triangles, it is going to be very, very cumbersome to do this in Blender. Even though Blender has excellent UV unwrapping functionalities, it will be too time consuming to use it within Blender. So what is recommended at this stage is, if you do not have it installed, then to also install MeshLab. It's an open source mesh editing software, and it has a nifty feature where you can unwrap an object into individual phases, which will be very time efficient and also totally adequate for our referential purposes for this mesh. Let's download it, the Windows 64 one. Let's open the installer and install it. Alright, we can run it immediately, or we can wait until we have properly exported the mesh so as to import it in MeshLab. Let's go back to Blender. Let's export this mesh. So select it, so let's make sure that it's selected, and then go to File and Export. Let's export it as an OBJ file. We should limit the exported geometries to selected only. We can leave the forward and up axis unchanged. We don't want any UV coordinates, we don't want any normals, we don't want to export any materials. And then we can slightly change the name of this. Tag mesh projected. Export. Let's open MeshLab, and then do File and Import Mesh. And let's move to the directory and open. Now the file is imported here. Let's see how we maneuver here. If we just click and drag, we will rotate here. And if we scroll in and out, we will zoom, and we can pan with the middle mouse button. And then we want to click Filters. We want to select Texture, and then Parameterization, Trivial per Triangle. So with the parameterization option trivial per triangle, all of the triangles of the mesh will be laid out in the UV space, triangle per triangle. And setting the texture dimension and the intertriangle border will make sure that these triangles are sufficiently far enough from each other so as not to produce inbleeding when textured. So we can select 8192 as our texture dimension and leave the intertriangle border to 2 pixels. Or we could actually change this to 16384, which is a 16K texture, if we might actually be able to project such a texture. We will see. Perhaps we will. The texture dimension that you choose here should reflect the projected texture that you want to project in Blender. So this might be excessive, depending on your computer specifications. Let's press apply. Alright, and we see here that the biggest triangles is 64 pixels and the smallest is 2.5 pixels. So 2.5 pixels, that's very small, but it's still larger than 1 pixel, so that might work. Then we can simply click close here, and having done so, let's go to File and Export Mesh As, so as not to overwrite the previous one. And then we can do, this one is not projected, it will be projected, but this is unwrapped. And then we don't want the normals, but we want to write the texture coordinates. That's good. Okay. And then we can close MeshLab, and then we can go back to Blender, and let's see here. Now we want to import the one that has been unwrapped, so let's go to Import, and import an OBJ. Since we saved it in the same folder as the previously exported one, it's here. And then let's see here, we don't need to change any of the import settings, so let's just do import. Let's make sure that this one gets a separate folder here, projected, to be projected unwrapped. Alright, and click and drag it to there. And now if we disable the visibility of the to be projected layer, we see that we still have this one in the same place here. We zoom in a little and then we see here there is no real difference in position, etc. And then with only this one selected, let's make sure that we apply the transform for this, because now since we exported as OBJ, which has a different forward vector, etc., it has been rotated 90 degrees along the x-axis. So let's just apply and apply all transforms. If we go to the UV editing workspace, we can just briefly check here, and then we must select all of the face here. We don't need to select all of the face, we can actually start by selecting some of the face here. And we will see here in the UV viewport the triangles of these. And you see that they are very, very small, and they are all unwrapped triangle per triangle. But with the referential nature of this mesh, the assumption is that this will be okay anyway. If we click in the void here to deselect, and then type A to select everything, then we see that everything fills up the UV 0 to 1 space very nicely. And it's quite hard to see, but when you go sufficiently close, then you see that they are all very neatly packed here. Alt A to deselect. And now we can go back to the layout workspace. So first we can change the view mode here to the solid view mode. And then we can also make sure that we show the texture. As of now we didn't see any difference, but when we now will create a texture, we will see it in the viewport. Let's see here. So we make sure that we have our object selected here, and then we go to the shading workspace. And here we see that we already had an imported material slot, material_0 from the unwrapping in MeshLab. And now we want to add a texture here. So Shift A to add, and then we add a texture and an image texture. And we want to make a new image texture here. And it can be called texture or T_projected_16K. I think that 16K resolution would be adequate for this large area, but also with the intention of not being too zoomed in on it during renders. If you find after baking that the resolution is too low, then you would increase this, but 16K is a very high amount. Be sure to take into account your computer specifications. I'll change the resolution here to 16384, and then I'll make sure to disable the alpha channel. It can be black as a background color image, and the generated type should be blank, like a blank canvas. Okay. And now that we have it here, we can just make sure that it's selected. The color space should be sRGB. We are baking color data in the sRGB color space to an sRGB color space texture. Then we can go back to layout, and we will find that everything is turned black. And the reason for that is because we have here in the solid view mode, we have texture set to color. So with the material, there is no other material color than the default gray. But for the texture, we have now selected in the shading workspace the texture to be projected. Very good. Let's go back to layout. And now if we go here to render and change the render engine to cycles, then we see that we have a new menu here, a bake menu. And here we need to change several settings. The bake type should only be diffuse. There should be no direct light or indirect light contributing to the bake texture. It should only be color. We can use the selected to active option here and expand this. We don't need a cage, but we should have an extrusion amount of some minuscule amount, so perhaps 0.001, that is 1 millimeter. This of course will need to be set depending on the imported object scale. So you might have to bake and test out and change the extrusion values if it does not produce a correct bake. The maximum radius can be set to 0, which is an infinite amount. The target here is an image texture. It can be set to clear the image. As for the margin type, we'll select extend. And then the size can be set to 16 pixels for this specific resolution size. If you use a larger resolution, you should use a larger margin. So as to make the selected active work here, we can activate the original here. And then we can make sure to first left mouse button click on the original mesh and then control click on the one we want to bake to. We see here that there's a small highlight here to make sure that it's the active object. And then we can simply click bake here. If you don't have a discrete graphics card, then you might just click Bake here, but since we have an NVIDIA graphics card here, we're gonna go first up here and change the device from CPU to GPU compute, and there, as it says here in the dialog, we should go to Edit, Preferences, and then enable CUDA. Very good. And as for this, we can leave only the graphics card checked here. Your mileage may vary with the different combinations. Alright, and before clicking Bake, we should select the object to be baked from, and then control click the object to be baked to, so as to render it active, and then we can click Bake. And now we'll just wait for the baking process. Baking will take some time. When it is done, you'll see that this progress bar has vanished. So let's see if we hide the original layer here. Yeah, and then we see that this is the projected texture then. And we should not expect here to have 100% fidelity in terms of resolution to the original texture, because the original texture was composed of many multiple texture sets, and each of those textures had a fairly high resolution. But let's see if we go for the windows here, as we did previously. You see that this is the original resolution, and then we hide that and show the projected one. And you see that it is clearly not as high as a resolution, but we intend to show this model perhaps from here and from here. The change is not that discernible. And the last step here is to actually save the internally baked texture here. So let's go to Shading, where we can easily access an image editor here that we have here. And then we can open this one, which is called the Projected, exactly, Texture Projected 16K. And opening that here, we see that it consists of a lot of baked triangles here. Each triangle having texture information. Very good. So then we can go to the 3 horizontal lines here and Image and Save As. And then let's see here, we can do a new one that is baked. And that's a good name for it. And then we'll change the file format here. I think that JPEG 8-bit is more than enough. We can do 100% quality, sRGB color space. Save as image. Now that image texture has now been externally saved and can be used as an input texture in any rendering software. Let's go back to the layout workspace, and then having selected the file here that we want to export, we should also export this. And this we have previously done in the workflow, so it comes as no surprise. Now the previous export did not include UV coordinates. We want to include that now, since we already unwrapped it in MeshLab, but we can disable normals here, since all surfaces should have flat normals in this case. There are no custom shading groups for this one. Let's limit to selected only, and we don't need to export any materials. We will create those separately in our rendering software of choice. And then we can make sure that the name here is proper, and then we export. And we can briefly test this out in Rhino. We should first change the unit to meters. Navigate to where we exported it. And import it here. And then we'll make sure to map OBJ-Y to Rhino Z, so as to make sure to import it in the proper orientation. Alright, and when the object is successfully imported here, we can expand the perspective here. We can look at it here, clicking in the void to deselect it. And it is quite complex to work with such a large mesh in Rhino here, but we will still see if we can use something here. So go to Material, we'll create a new material here. It can be a custom material, and it's a very simple material, no certain reflectivity, and the color should be a texture, assign a texture, and then we should browse to that and open. So now we have it here. If we change the view mode here, let's first position ourselves, and then we change the view mode here to shaded, or more precisely to rendered. Very good. So here we have it. Very good. One final note here is that it's recommended to reference some ground truth data, such as geese data from Lantmäteriet or some other surveyor's agency with a fixed and reliable scale, and then simply scale this object to that object by referencing it. It has been stated that the scale of the imported data when extracted from Google Maps should be 1 to 10. So then you can actually just do scale, and then base point can be the origin, and then 10. And this should yield a correct scaling, but don't trust it too much. Let's render this. Let's close Rhino down here, And although it was not the intended aim of the tutorial, let's also import it into Unreal Engine so as to see how it looks there. Alright, so now we are here. Let's just dismiss this. And then we can actually do new level. It should be an empty level. Create, and then control spacebar to open this. I'll just make a new folder here. And in here, maps, and then we can save this level in that specific folder, and then this is a level, and we can just do ultra dynamic sky. I think is appropriate. And then let's see if we open this again, and we'll go back here, then we can simply click and drag in this here, and of course this should not be in here, so we'll click cancel, and then we'll do here, and then we can do a new folder, architecture, and in here it can be Google Maps, and in here it can be very good. Alright, the asset name can be static mesh underscore campus. That's okay. Nice and short. The scaling we'll have to fix. It was saved as a centimeter file, which is the Unreal Engine unit, and it was on a scale of 1 to 10, and it should be then 1000, because 1000 is 100 more than 10 centimeters, which it should be. And then we'll see here, we don't need any vertex color. Normals can be recomputed, and tangents can be recomputed using McTangent space. Weighted normals should be computed. We don't need any skeleton. We don't want to build nanite for this specific mesh. We want to generate light map UVs. The scale has already been offset previously. We don't want to import skeletal meshes, which renders the following irrelevant. We don't want to import any animation, which renders the follow irrelevant. We don't want to import any materials. We don't want to import any textures. We'll import that separately, and then we can import. Alright, import was done. Let's see here. We don't have a thumbnail preview yet, but we will have soon. Let's double click on the file to verify that the scaling was correct. It looks a little funky, and we see here that it has been imported with an erroneous orientation, but the scaling is good. So I'll simply save this here and close this, open the content browser, and drag this out in the world here. Let's see here, reset the location, rotate around the x-axis 90 degrees. Let's see if we move here and see if this looks correct. Yeah, it looks correct, like houses extend upwards. Here we'll do a new material, so material, campus. Open this material, hold T and create a new texture, and this one, yeah, we'll need to import that as well, of course. So let's open the content browser here and maneuver here to the baked directory and drag this in here, and we should open this just to make sure this is the correct compression settings. Yes, default one is good, and it should be sRGB checked. Very good. Then we can save this. And then we can select that one here. So campus. No, sorry. And perhaps we should change the texture name here. So with F2, texture, campus, 16K. That's okay. And then we can go back here to the material and select campus. That one there. Very good. Connect that to base color. Very good. And for metallic, let's assume that there are no purely metallic objects here, so let's keep it at default 0. For the specular one, we can do like this. We can drag out the red channel here, do a lerp, and this one should be the alpha. So let's drag out there, and then it can be from 0.5. So the red channel value will be linearly interpolating from 0 to 5 to 1, depending on the input value of the red channel. We'll input this into the specular. And then as for roughness, we can actually do something similar. So Control D to duplicate, and we'll do the red channel again. We will change the linear interpolation range here, so that it is from 0.8 to 0.95. And put that into roughness, And as for the other material aspects, we don't have anything really to enter. So let's just make this a little tidier and then save it. And we can either apply it to the placed object here, or we can apply it here, and we'll do it here, campus, like that, and then we can save. Alright, so the next thing we should do is, in this case, to open the Epic Games Launcher, to search the vault for Ultra Dynamic Sky, which is a paid plugin. Add it to the project. Very good. Now I can minimize this again, and here we can go to Ultra Dynamic Sky, blueprints, and then we can drag out the Ultra Dynamic Sky blueprint here, like that, and it immediately looks more than slightly better. And then let's see here. There we have the sun and moon targets. Let's make sure that these are in the origin here. Oh, let's see it now. We selected everything, so let's go back to SM Campus, and they should be here. Exactly, very good. Regarding the north orientation here, we are gonna overlook this. We can just position the sun so that it is co-aligned to the shadows of the imported texture here. So if we'll do like this, we'll go down here in the settings and make sure that we select Stockholm as our coordinates. Let's make sure that we find this first. Here, very good. Location preset should be Stockholm. Like that. And then we can adjust the north jaw here. Let's see. Aha, okay. And to make this work, we should also simulate real sun. We can do moon and stars as well. And let's see now. So now it is there, and it should be. And these sort of photogrammeters are usually done in the summer when activity is low. So let's do 6. And then we'll change the jaw. And let's see which one it should be. Yeah, we'll go all the way around then. Let's see, where are our shadows here? We can find that here, I think. Alright, so then we'll see here. Yeah, it should be somewhere like that, and then we might adjust the time. Or simply the month. So let's see here. We want to make it even higher, like that perhaps. Yeah, and this can be of course fine-tuned, and if the orientation of the imported mesh would be according to the north, then it would be really easy. But let's do it like this. Yeah, and then we position us somewhere where we find that the view is looking good. Perhaps approximately here, and then we'll do create camera here and a CineCamera actor. Very good. And we can pilot this like this. And the question is if we should use, I think really we should, if we have the camera settings here, let's make sure that the film back here can be initially set to full frame DSLR, and then we can change so that the sensor is constrained to 24 here as well, so we get a square format here. And then we want to make sure that the focal length is greatly increased, and while increasing the focal length we of course also want to move the camera backwards, and I think this is most easily achieved if we do like this, and then we can, let's see here we have it positioned there, and then we can stop piloting here, eject from it, and here we see it, very good. And then we can change to local, very good, and then we can move a long way far. Let's see here, that might be enough. Let's go here again and Control-Shift-P to pilot, and then perhaps somewhere along here perhaps. And with Ultra Dynamic Sky we can see now we have 960. Oh, but this is looking fairly good. Regarding exposure, etc., we can just leave them at default values for this one. 960 it was. Very good. We can save everything with Ctrl-Shift-S. And then we want to create a new sequence, a new level sequence. So we'll go here and add a new level sequence. And then we'll make sure that this can be named perhaps level sequence and then tutorial test. Google Maps. That's okay. Save. Alright, we should add and track the actor to the sequence, the CineCamera actor, so that we can control it here in the level sequence. We should also track specifically the ultradynamic sky blueprint, but we don't want everything in that. We only want the, let's see, which one is it? The time of day is the one we want. Here we have it, time of day. Very good. So now we have that as a component that we can control here in the level sequence. Very good. So 960 was the default. Then we want to see here how long should this be, perhaps 8 seconds or so. So let's see here, 8 times 30, that's 240, so we want 240 frames here. So let's see here, somewhere around there, and we extend this, not move it, but we extend it to 240. Great. And then we perhaps want to, for frame 1, the index 0, we add a time of day. So we add here a new key, and we should perhaps have it set to something that's completely black or so. And I see here, the exposure here we need to adjust anyway, so as not to make it adjust too much, as you see as it does now. So we should, let's see here, we should add a new tracking here, and that should be the post-process setting. And then let's see here if we do have, yeah, the lens exposure, and then we can do exposure compensation as the tracked one, and then we can, for the settings of the CineCamera actor itself, we can make sure that it is manual, and then we can adjust the exposure compensation as we want. That's very good. Yeah, and 15 looks like it's the largest, but we can enter 20 and it's 20. Very good. So this one, exposure compensation, is a value we can control here. So let's see, if we then go to sort of the middle and then create a new day, sort of say, and then we'll make sure that this is 960 then, 960. And then let's see here, let's also make positively sure that we have game settings here. Very good. So now we can adjust the exposure compensation so that we like it. So perhaps like a sunny day, somewhere around there, or perhaps there. So now it's actually turning dark here in the beginning. Great. We have some wind in the direction, or some clouds moving there, that's okay. And then we might actually produce 250 here. And then let's see here, that will move actually this all the way here. And then we'll change the time of day to be evening then. 2400. Because now I guess that we would have then a full day here. It might be a little long until the day actually starts here. So we can, if we click this one, and then we can do 300. And one thing to take of note is that these should not be set to the cubic one, they should be set to linear, because the sun moves linearly across the sky and not in a smoothed way. So let's see here, if we try to play it out now. Yeah, looks okay. Ah, this is wrong. This is actually very wrong. Okay, so let's see. The timing there might need to be changed. That's okay. I'll save this level sequence and then I'll close this and eject this. And then it is my assumption here, it was a misunderstanding here, because the time of day might be around 12, and now the sun is clearly where it should not be. Yes, so let's adjust the jaw position to perhaps there. Much more reasonable. Alright, since that parameter was not keyed in the level sequence, I think that we will have a good result now. Let's go back to the level sequence. And we are not piloting here. Let's see here. Where is our camera then? Let's pilot it here. Yeah, this is much more reasonable in terms of the orientation. If you want to get rid of that level sequence icon, we can just press G, while here, G, to go to game view. The addition of some camera shake might be advisable, but then due to the time-lapse nature of the scene, it might be a little inconsistent with what we would see. So the one thing that we can add would be some depth of field. Let's see if we do like this. We can exit the sequencer and make sure to exit the piloting here as well. And then we can do like this. So then we can quickly add to the project a basic actor, but we should do a shape, a basic cube. So here we have a cube, and it is set to a focal point here. So we can go there and move it to there. That's good. Let's make sure that this actually is invisible. So let's check the visible to false, or uncheck it. Very good. We can rename it to our focal point. It is a static mesh, it's okay. Static mesh focal point. Great. And then let's see here. I think it's easiest if you go to the CineCamera actor here. And we are still in game view, so now we see it. By pressing G, you toggle game view, and we can change the location of that since that was in the way. With this one here, and I see that it's very dark, so it might be impossible to view as of this, but it's okay. And then we'll do like this. We'll go up here, I think it is. And then we do have a focus setting, and we'll do a focus setting, and it should be, and the focus is different from the look at, very good. Because the look at should be at another focal point, so to say. And then we can do a tracking one, and the one that we can track, the actor, and then we can just do focal point here. Very good. And we can draw the debug focus plane here. And yeah, we see it, but it's quite far away there. So there it is. It should focus there. So now we can actually go back to the level sequencer. And then we should pilot the CineCamera actor, and we should go to perhaps the middle of it, perhaps there. And now this might be a little finicky, but let's see here. Let's make sure that we can open the aperture even further so as to create a more shallow depth of field. So let's go to lens settings, and then we'll change the minimum f-stop to 0.05. And then changing the aperture will, as for real cameras, also change the exposure. So when we go down here to the current aperture and set this to 0.05, it will be very, very bright. And as such, we should go down to the exposure here and set a lower exposure compensation. And we see it, that since we are so very, very far from the subject, even though we have an aperture that is insanely large or wide, with a very, very small f-stop value, we still don't get the depth of field that we intend. So let's decrease the minimum f-stop value even more, and then also change it here in the current aperture. And we will have to compensate with the exposure. But now we see that we get something of what we want. We have a very, very, very blurry image in the beginning here. Perhaps that was a little too much, so we'll increase, perhaps double or half the aperture opening, but double the f-stop value. And then we'll compensate with the exposure. like that, and then we'll see how this looks. I will have to, of course, get rid of the debug plane before we render. Yeah, but that looks good. And I think that, yeah, as stated previously, a little camera shake might be beneficial. We will not delve into that as of now. So let's make sure that we go to the settings here and that we make sure to hide the debug plane. Great. And we can save everything with Ctrl-Shift-S. Great. So now we have 240 frames to render. Perhaps we can render out just a test render here at perhaps frame 170. And we'll go to Windows, Cinematics, and if we don't have the movie render queue, as we don't have here, then we'll simply save everything. Everything was saved, and we can actually close the sequence and not pilot the camera. And then let's see if we go to Edit and Plugins. Let's search for Movie Render Queue. Movie Render Queue, there we have it. And then we also want to enable the Avid so that we can immediately export to a movie file. And having done so, we can restart. Alright, then we can close the plugins here. And we can close the content browser. We can still access it by Control Space. And then we go to our level sequence. Oh, and it's another level, of course. So let's first open the level, recent level, the Ultra Dynamic Sky one. And then in here, we as of now don't see anything, but now it reappeared. So then we'll open the level sequence here. And now, having opened the level sequence and looking at it good, we don't need to have it open to export, so we can actually close it just to showcase that one. Alright, then we can go to, and I'll make sure that while we render, we should not have real time on here in the viewport. Good. Window, Cinematics, Movie Render Queue. And then we should render, and it should be the tutorial test Google Maps one, that level sequence. And then let's see here, the settings. First make sure to expand this. It looks good. Then we'll expand this, and then we should not export a JPEG sequence. Or actually, we said that we were going to do frame number 170 as a test. We can do a JPEG sequence then. And then as for the deferred rendering, everything looks good. We want to adjust anti-aliasing and make sure that we have spatial sample count of perhaps 8 and 8. Is that enough? And we should make sure to override the anti-aliasing method so that there's none. And I think that, wasn't it for the spatial one that we can do 16 and then a temporal 8? But this is something you'll have to experiment with. Later on we will export as an Avid DNX, so we can do that actually now, but then you simply to disable it. And as for the output, yeah, we don't want a resolution that is not in a square format, since we have a square format intention. So let's do 1080 here. And then the frame rate can be set to custom, 24 FPS. And then let's see here, if we do the custom playback range, should be custom start, should be 169, and then custom end 170. That should render one frame, since it goes from one frame to another, and that is one frame that gets rendered. Alright, so this is a JPEG sequence. We will only render one frame. Deferred rendering, everything looks good here. Anti-aliasing, no anti-aliasing method, instead you're relying on spatial samples and temporal samples. That's good. Then we can accept this. And having accepted that, and we see that we have this shot that we already have in the level sequence, we can simply do render local. Alright, yeah, so it starts on a subframe, render range has to be rounded to the previous frame, that's just a warning, not an error, that's okay. Let's make sure to open that file. It will be saved in the project directory, saved movie renders. So we can do like this, new, and then this one should be then in Unreal Engine, projects, this one saved, movie renders. And here it's important that if you do consecutive work, like these will be overwritten. Let's see if this works. Yeah, it seems as though there was some cloudiness, but that's okay. The depth of field might be a little too excessive to my taste. So let's reduce that. It's good. It can be good to just use one frame and see if there are any settings which should be changed here. So let's decrease that depth of field effect. We could save the config files, but they will be stored here until you close the editor. So let's see here, so we can open our level sequence here. and then we can go to some mid-frame here, and then we can pilot, and then we see that it was a little too much, so then we'll reduce that effect by going to the CineCamera actor settings, changing the current aperture perhaps to 1/5 of that effect, which was the same as we previously set, if I recall correctly. Perhaps then do 3. Go down here to the exposure settings and then change the exposure compensation, like that. And does it look good? It looks good. Let's save everything then, and then we can close the sequencer, make sure to eject from the piloting, and then we can do movie render queue, and then everything is saved here, or like nothing has changed here, so we can just render local. And this was the warning that I said later, that it will be overwritten. Yeah, but it's more reasonable. And as a still frame at a low resolution, we know that the data itself has its shortcomings, so we're not too interested in like being too zoomed in here. We might actually be able to increase the resolution. So perhaps we'll do double, which is a quadruple amount of pixels, 2160 times 2160. And then we can try that one again. It will be overwritten. Yeah, okay. Let's see here. Yeah, and we clearly see that we don't want any more high resolution than this, since the data itself, it shows these shortcomings. We can leave it there. It doesn't matter if it gets overwritten, but as of now we will change the setting here so as to not export the JPEG sequence, but instead the Avid DNX movie file. It will be 8-bit as the JPEG. So remember that if you want like a higher degree of fidelity to the color values, then you'll export as a 16-bit, perhaps a 16-bit EXR then. Alright, as for the output, let's make sure that we have a custom playback range. It can be 0 to 240. Alright, accept this and then render local and just wait. Alright, so with that saved, I think it's the most important thing is actually to change the name slightly so as to not make sure to overwrite it by accident. So we can do just 00. And then we can see how this looks. We'll open VLC. Yeah, and it's not perfect in any sense, but still one way to use the Google Maps as reference data for a light study. Thank you for your time.